Hello students, I'm Dr. Arpita De. A very warm welcome to all of you here. The topic for today's discussion is ultrastructure of ribosomes. The moment we listen to the word ribosome, what comes to our mind? Ribosome, from our junior classes, we have studied that are associated with protein synthesis. It is also otherwise known as protein synthesis machinery. So, before we start about its ultrastructure, let's first talk about its origin. Various studies suggest that ribosomes originated in an RNA world. It was entirely composed of rRNA and later evolved protein synthesis ability. Ribosomes are basically composed of ribosomal proteins and rRNA. Ribosomes are dense spheroidal particles that are found to occur freely in the cytoplasm or are attached to the endoplasmic reticulum. You all know that endoplasmic reticulum is of two types, rough endoplasmic reticulum and smooth endoplasmic reticulum. The rough endoplasmic reticulum is studded with ribosomes. This is why it is rough in nature, and the ones which are devoid of ribosomes are smooth in nature. These organelles are not bound by any membrane. Okay? The chief function or its chief involvement is where it is in protein synthesis. George E. Palade in 1955 discovered ribosomes. Please make a note, it will be George. George E. Palade in 1955 discovered ribosomes. Now let's come to its structure. Ribosome has got two subunits. One is the large subunit, the other is the small subunit. The two subunits together form one complete ribosomal unit or the complete organelle. Ribosomes are composed of RNA, 37 to 62% of it is RNA and the rest is ribosomal proteins. Now let's come to the various types of ribosome. Both eukaryotes and prokaryotes are found to contain ribosome in their cell. Eukaryotic ribosomes are 80S and prokaryotic ribosomes are 70S. This S stands for Bedford's unit, which is used to measure the rate of sedimentation in a centrifuge. How fast does particle sediment in a centrifuge? This is a measure of that, and this abbreviation, the term has come from the name of the great scientist who had given us this idea. Now let's see a brief comparative account of eukaryotic and prokaryotic ribosomes. Eukaryotic ribosomes are 25 to 30 nanometer in diameter, while the prokaryotic ribosomes are 20 nanometer in diameter. These ribosomes are a bit longer in the hinge region than the diameter. The molecular weight is approximately 4 into 106 Dalton in eukaryote and 2.7 into 106 Dalton in prokaryotes. The larger subunit of eukaryotic ribosome is 60S and the smaller subunit is 40S. In prokaryotic ribosome, the larger subunit is 50S and the smaller subunit is 30S. In eukaryote, you see the larger subunit, the 60S subunit, has got 28S, 5.8S and 5S rRNA molecules, which are bound to 30 proteins. And the small subunit, the 40S subunit, contains 18S RR molecules and are bound to 30 proteins. Similarly, let's come to the prokaryote site. The larger subunit of ribosome in prokaryote has got 5S and 23S RNA molecules which are bound to 31 proteins. The smaller subunit has the 30S one has got 16S rRNA which are bound to 21 proteins. So this is a brief comparative study about the two ribosomes which are about the ribosomes which are available or which are found in eukaryotes and prokaryotes. Now let's see about its structure. In a ribosome, you see one large subunit is there, one small subunit is there, and this subunits together take part in the synthesis of polypeptide chain. This has got an E site, a P site and an A site. These three sites are associated with an mRNA that binds to the small subunit. In prokaryotes, during the initiation of translation, an initiation complex forms which contains the small subunit which is associated with the mRNA. These three E site, P site, A site, and ultimately the large subunit binds to it. This is how translation commences. Okay, now let's see what are these. A site is your amino acyl tRNA binding site. Okay, this is the site where a new tRNA carrying amino acid arrives. So a new tRNA which is carrying a fresh new amino acid will arrive at A site. It will come and it will scan for its matching codon in the mRNA. If the tRNA codon is successful in finding its matching counterpart in the mRNA, then only it will sit there. And what will happen? It will form a peptide bond with the amino acid that is there in the P site. What is this P site? P site is your peptidyl tRNA binding site. So, initiated tRNA is positioned in the P site. The initiated tRNA will come and be positioned in the P site. And finally, what is the exit site or E site? E site is the site from where the empty tRNA exits the ribosome after it delivers its tRNA. So, the primary function of ribosome is protein synthesis. This is what? It is nothing but decoding of mRNA and generation of polypeptide chain. Let's quickly see the process in brief. How is it taking place and how is ribosome playing such a great important role in forming the polypeptide chain? The process is initiated by formyl methionine tRNA positioned at P site. This is also known as F-met tRNA. It contains formyl methionine and it is positioned at the P site. A new tRNA carrying amino acid arrives at A site. If it is successful in finding its matching codon on the mRNA, then it will be positioned there, or else it will leave and a new tRNA will set in. If the codon of tRNA and that of mRNA matches, then a peptide bond is formed between the two amino acids and the ribosome travels a distance of one codon. So as the ribosome moves a distance of one codon, what will happen? The position changes. Fine. The tRNA, after delivering its amino acid to the growing polypeptide chain, is now empty and exits the ribosome from A site. A site is again ready to receive a new tRNA carrying amino acid. So this is how the process goes on until it encounters a stop codon. So when a stop codon appears, this brings about the termination of polypeptide chain synthesis. So translation comes to an end when a stop codon appears. We will not be discussing about the entire functional details of ribosome in this lecture, since we are only focusing on the ultrastructure of ribosomes here. I hope this video is of use to you. I would request you to pause the video in between and make your notes in your exercise books. In case you have any doubts, any confusion anywhere, please feel free to get back to me in the comment section, and I will try my best to clear all your doubts. Thank you so much for your kind attention, and hope to see you soon. Bye-bye.